Alrighty, so you guys are doing more sequences of transformations. Alright? So it looks like you have quadrilateral if FNWY, and I see it here on the grid. Alright? And number 1 asks you, draw the quadrilateral that is the result of a translation left 4 units, up 8 units, and then rotate it 90 degrees clockwise about the origin. All right, and then we're gonna label the quadrilateral we get after doing those two transformations GLTX. All right. So actually, we can fill out the first part of this table here, right? The first transformation we're gonna do is we're gonna go left 4 units and 8 units up. All right. So essentially, we're gonna take every vertex here. Right, we're gonna go to the left 4 and then up 8. All right, so my first transformation is gonna be a translation, and of course that's gonna get me f prime, n prime, w prime, y prime. All right, and how can we describe that algebraically? Well, what are we doing to our xy coordinates? Well, it tells us here, right? So our xy coordinates, right, will be changed. Our x will go to the left 4 units, so it'll be subtracted by 4. Our x will be subtracted by 4, our x value subtracted by 4 units. And our y value is going to go up 8 units. Alright, so it'll be adding 8 units to our y values. Alright. So let's actually do this then. Alright, so we're going to apply this transformation to this quadrilateral. So f will go to the left 4, so it put me at 1, 2, 3, 4 at negative 8. All right, and then I'm going to go up 8. All right, so 1, 2, 3, 4, 5, 6, 7, 8. So f prime would be at negative 8, 6. All right, and I guess I should write that here. F prime will be at negative 8, 6. It looks like n would be at, well, if I go to the left 4, so 1, 2, 3, 4, it'd be at negative 2. So I'm just gonna write that as I say it, so I don't forget it. N prime would be at negative 2, and then I'm going up 8. So 1, 2, 3, 4, up 8. So 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, 4. In prime, we got negative 2, 4. I know it's kind of hard to see on that graph there. The print is not so dark. Alright, y will be at, well, let's see. 1. Y looks like it's at negative 3. So 1, 2, 3, 4. So it'll be at negative 7 and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. So y prime, I'm sorry, I should have said that. I'm not sure if I said y prime, but y prime would be at negative 7, 2. So y prime is at negative 7, 2. Alright, and then we have w. Okay, we need to translate w. Okay, we need to go to the left 4 and up 8. So 1, 2, 3, 4. That put us at negative 3. And then up 8. That put us at 1. So negative 3, 1 would be w prime. Alright, so we have created our new quadrilateral, and I'm just going to come in here with a ruler and do so. It's not going to be perfect, but alright, and there is our new quadrilateral f prime, n prime, w prime, y prime. All right. All right. Okay, but we're not done yet. Okay, we still need to rotate it 90 degrees clockwise about the origin. All right, and again, about the origin just means you're rotating it, and I could do it in a different color here. You're rotating it around this point here, the origin. All right. So let's fill in the second part to our transformation. We're rotating it 90 degrees clockwise. And you guys have an algebraic description for this. All right, it should be on the whiteboard on the back of the room. What is the algebraic description for a 90-degree clockwise rotation about the origin? All right. It is your xy values will become y x. Negative x, sorry. Y negative x. Alright, and that's all happens. So your xy values will flip and your x will become negative. Okay? So I guess it's good. That we wrote down the coordinates as we went on. That way we can just apply this algebraic description to those coordinates. Alright? Alright, so now let's rotate this. Okay, 90 degrees clockwise. Well, look, we have the rule here. Okay, we're just going to plug in those, I guess every coordinate, we'll plug this algebraic description in for it, and we'll get our rotated 90-degree clockwise quadrilateral. All right, so my xy will flip and my x will become negative. So where will, and I'm assuming f prime, right, will match up with g. So where will g be at? Okay, where will g be at? All right. Well, if I flip these, all right, it becomes 6, negative 8. All right. But look, our x becomes negative. But our x is already negative here. So that means it'll just become positive. And I'll just erase that. That would be f prime would become g, which is 6, 8. Or it rotate onto g, which is 6, 8. All right. In prime, we do the same thing. We flip and our x becomes negative. All right, so in prime would fall onto, looks like L. So our L coordinate would be, well, again, we flip. So it'd be 4, negative 2. All right, but our x becomes negative. All right, so our 2 is already negative. So it becomes positive. All right, it becomes positive. All right, same thing with y prime. All right, y prime will transform onto t. All right, so t will sit. Again, we flip and our x becomes negative. So to negative 7, but again, it's already negative, so it just becomes positive. All right, I'm just following this algebraic rule here. Okay, so t would sit at 2, 7. All right, and last w prime. All right, again, we're gonna flip them, and our x becomes negative. So w prime would sit on x after it's transformed. So our x coordinate would be 1, negative 3. But again, our x became negative. Okay, so even though I flipped it, okay, our negative then becomes positive. All right, because it was already negative there. So we just created all of the coordinates for our quadrilateral GLTX, all right? And that's what this quadrilateral will rotate onto. All right, so let's just plot the points now. All right, 6, 8, so 6, 8, 6, 8 would be here. That would be G. L would be 4, 2, so 4, 2. Or I guess, well, I'll let you catch up. G was at 6, 8, so it's there. All right. L is at 4, 2, so 4, 2. This would be L. All right. T is at 2, 7, so 2, 2, 7 up here. Where that's T. And then X is at 1, 3, so 1, 3, and that would be x. All right. So my quadrilateral would look like this after being rotated 90 degrees about the origin clockwise. Okay, after being rotated 90 degrees clockwise, and I can't really see here, so I'm gonna try to eyeball this as best as I can. It looks something like that. All right, and that's it. Alrighty, let's move on to number 4. Alright, it says complete the table of values for each quadrilateral. Alright, and I guess we, oh look, I guess we kind of time traveled there, right? It looks like we already did these ones. Alright, so I'm just going to fill in then. We knew f prime was at -8, 6. We knew n prime was at -2, 4. We know w prime, I guess I labeled that wrong up here as I was doing it. F N Y F N, yeah, I did. It should be F N W Y, but it still works. So W prime should be at -3, 1, and Y prime is at -7, 2. All right. GLTX, we got that up here. Okay, G is at 6, 8. L is at 4, 2. T is at 2, 7. And X is at 1, 3. Alright, so now we just gotta find the coordinates of F, N, W, Y, which I guess I should have done at the beginning of the lesson, but I guess we can just do it now. So F will be, F looks like is at -4, -2. So -4, -2. It looks like N is at 2, -4. W is at 1, -7. And it looks like Y is at -3, -5. I'm sorry, -6. Y is at -3, -6. Alrighty. Alright, let's flip to the back. Alright. So it says, explain how the tables for the quadrilaterals F, N, W, Y and F prime, N prime, W prime, Y prime show the effect of the transformation on the coordinates that result in the algebraic description. Alright. Alrighty, so one way to think about it, right, is all the coordinates, alright, from quadrilateral F, N, W, Y to F prime, N prime, W prime, Y prime, right, all the points, they moved the same distance and direction, alright? So, if we look here, all these points, right, all these points here, they all moved by the same direction to get here, alright? And that's what we have here. That's how we made our translation. It all moved to the left 4 and up 8, alright? So, the way we would answer that, alright, all the points moved the same distance and direction. Alright? each coordinate changed by the same amount. That's how we knew the algebraic description for our translation. I know it looks a little sloppy there, but I'm going to go ahead and give you some time to write that down. And I'll read it out loud again. All the points move the same distance and direction. Each coordinate changed by the same amount. That's how we know the algebraic description for our translation. All right. And that's just how we knew that. Alrighty, let's look at number 6. Alright, it says explain how the tables for quadrilaterals f prime, n prime, w prime, y prime, and GLTX show the effect of the transformation on the coordinates that result in the algebraic description. Alright, and again, we can apply the same logic here. Okay, and I'm gonna flip to the back so you understand. Alright, so how do these tables here help us understand, right, the effect of the coordinates? Well, it looks like they all flipped and your x became negative. All right, and it looks like every coordinate followed that rule. All right, it all followed that rule, and we know that if all of the coordinates are flipped and your x becomes negative, and that's what we denoted up here, all right, then we know that a 90-degree clockwise rotation happened. All right, so again, I'll say that one more time. These two tables, all right, it shows us that every coordinate, okay, every xy value of every coordinate reacted the same way. They flipped and the x became negative. All right, so that tells us it was a 90-degree clockwise rotation. All right, and that's how we would answer that. So every coordinate all right, xy flipped and the x became negative. Telling me my algebraic description of a 90-degree clockwise rotation. All right, and I'll leave that up there for you to write. All right. Every coordinate xy flipped and the x became negative, telling me my algebraic description of a 90-degree clockwise rotation. All right. Alrighty, so let's look at the next one. It says triangle XKG is shown on the coordinate grid, and I see that here. Okay, so it says draw the triangle that is a result of a rotation 270 degrees counterclockwise about the origin, and then reflect it across that y-axis, right? And we're gonna, once we're done with all that, we're gonna label it triangle x prime, g prime, or sorry, x double prime, g double prime, k double prime. All right. All right, so let's perform the first transformation. All right, and we already know what it is. It's a 270-degree counterclockwise rotation. All right, so I guess I can fill out the first part to this transformation. Is we're gonna 270-degree counterclockwise rotation. All right, and we already know the algebraic description for this. It's on the whiteboard in the back of the room. All right, but if we rotate 270 degrees clockwise, counterclockwise, all right, our xy coordinates, all right, what happens to them? Well, it looks like they flip and your x becomes negative. They flip and your x becomes negative. All right. So that's what they want us to do first here. So in order to do that, well, we need the coordinates of this first. All right. So I'm gonna go in here with a different color. That way you can separate it from the words up there. All right. So where is G at? Let's get the G coordinate. G is at 5, 7. Or I guess we should do it in order, right? How the triangles labeled here. So let's do x first. All right, so x is at 6, 2. I wish I was 6'2". All right. G is at 5, 7. All right. G is at 5, 7. Man, even 5, 7 would be nice too. All right. And K is at 3, 4. But at least I'm not 3, 4, right? All right. So we're going to rotate it 270 degrees counterclockwise first. We already have our algebraic description, so let's just apply that, right? So if I flipped these coordinates at my xy and my x becomes negative, what am I going to get? So x prime, okay, and this is, I'm going to flip it, right? So x prime should be at, I'm going to flip these, 2, and then my x becomes negative, so 2, negative 6. All right. G, right, flips, and my x becomes negative. So 7, and my x was positive here, so it becomes negative down here. Negative 5. All right, and then my k prime, and I forgot to put the g prime there, g prime, and then the k prime, right? They flip, so 4, but my x becomes negative, so it'd be negative 3 down here. All right, and then we could just plot these. All right, and that'll show me where x prime, g prime, k prime will lay, and that's the result of of our first transformation. All right, so x prime is at 2, negative 6, so 2, negative 6. So that is x prime. G prime is at 7, negative 5, so 7, negative 5. That is G prime. All right. And K prime is at 4, negative 3. So 4, negative 3, which is here. That can be K prime. All right. And then I'm just going to make my triangle. I had a ruler and I still made that not straight, so oh well. Alright, so your triangle will look something like that. All right, that's actually bothering me. I'm gonna fix that. Let's try this one more time. All right, there you go. That's a little better. All right. But we're not done. We have one more reflection to do. All right, we got to reflect over the y-axis, right? Over the y-axis, which is this line, all right? So we can label this then. Our next transformation is a reflection over y-axis. All right, and we have an algebraic description for this, right? When we reflect over the y-axis, right, and it's pretty intuitive why or what would happen to your xy coordinates, right? But on the back of the whiteboard, again, like I said, in the back of the room, you see that your xy will just become negative xy. All right, and you could think why that's true. Well, I mean, if you reflected x over the y-axis, right, it'd be over here, right? You still have the same y value, but now your x just becomes negative, right? Because you're on this side of the grid. All right, but we can just apply this now to our points. All right. So let's start with x prime. All right, x prime. All right, your xy would stay the same, but your x becomes negative. So now I'm gonna write this here now where x double prime would be. All right, it'd be at -2, -6. All right, and you could also know that just looking at the grid. Well, it looks like it sits 1, 2 away from the y-axis, so you sit 1, 2 right here on the y-axis. So that'd be x double prime. But again, I just applied the rule, right? My x becomes negative, my y stays the same. All right, so remember x prime, your x and y stay the same, but your x becomes negative, all right? So that's why I got -2, -6. All right, g prime, all right, will reflect over the y-axis and give me g double prime. All right, and what would that give me? Well, my x just becomes negative. So, and again, I'm just applying this rule to this, so it becomes -7, -5. All right. And again, you could have just seen it as, well, g is 7 units away from the y-axis, so if we reflect over the y-axis, it needs to be 7 units away on this side, which would be -7, -5. That'll give you g double prime, right? And then you have k prime, all right? We got to reflect that over the y-axis. All right, well, we know k prime is at 4, -3. All right, my x just becomes negative, all right? So k double prime would be -4, -3. All right. And again, you could just look at it too. Logically, it is 4 away from the y-axis, so it needs to be 4 away from this side. So it puts you at -4, -3. That would give you k double prime. All right. And we could just now draw the triangle. Hopefully it comes out a little better this time. Yeah. Alright, and that's what it would look like reflected over the y-axis. Alright, in this last question, alright, let you look at that for a little bit longer if you still need to copy it. Alright, this last question is pretty simple. Okay, it says describe the connection between the algebraic description. So what about this and of the rotation and the vertices of x g k to x prime g prime k prime. All right, so what connection, all right, of the rotation, which is here, right, all right, and the vertices from that to that, okay, what can we say about them? What connection does these vertices of x, g, k have with this? Well, again, a simple way to say it, right, is all of the vertices reacted, right, reacted accordingly to the algebraic description. All right, and I'm not sure. It's almost like they're asking this again. All right, I kind of think they asked it up there. Oh no, that was from the previous question. Just now it's a new question. All right, so what connection does this algebraic description, all right, have of these vertices, right? Well, again, we kind of already said that, right? It looks like all of the coordinates, all right, 6, 2 became 2, -6. 5, 7 became 7, -5. They all flipped and the x became negative, all right? So it just, the vertices, I guess, followed, all right, that algebraic description, all right, and that's all I guess you would say for number 10. I'm not sure of a better way to answer it, all right. All right, so I would say the vertices all flip and the x becomes negative. That is the algebraic description for a 270 degrees counterclockwise rotation. All right, and that is all. Okay.